A little bit, and I am not in the program, so I apologize for that. But my project is a speed detection camera, and I use a lot of similar methodology to the parking space algorithm. So the basic idea for my project, this did come from Dr. McCrainer. Everyone speeds. I mean, I know every single one of you has gone over the speed limit in your car before. And it's really dangerous in residential areas, especially with people who have small children who play in the road, pets, like Dr. McCrainer said. It's really dangerous if you speed through a neighborhood. And if you want something cheap, the Raspberry Pi, which I'll explain a little bit more in depth later, it comes in at around $35. It's a very, very basic computer. So it's a very convenient thing to use for this type of thing if you want to take action yourself when the authorities are not always around, especially in residential areas. They don't patrol those areas very much. So people who get very frustrated with speeders who are constantly in their neighborhood, this is a way that you can kind of take charge and do it yourself. Oh, that's a double tap sometimes. Okay, so the two main methods for detecting speed are radar, which is the traditional method. Those are the police guys that you see doing this. They're using radar. It's been around for over 50 years, and how it works is it uses the Doppler effect, which gives you a change in pitch due to the relative motion between you and the speed of the object that you're measuring. And since radar has been around for so long, there are now many illegal (parentheses) methods of messing with radar. People can buy signal scramblers that will kind of mess with the frequency of their engine and the way that you can measure that frequency with the radar. So it'll give the police just a meaningless signal. There are those things that you can mount to your windshield that will tell you when radar is being used in the area so that you will purposely slow down. And also, radar is not effective in angled rain. So if it was raining and it was not completely perpendicular, those measurements would have to be completely thrown out. So I chose to use the second method, which is image detection. And it is much more accurate, but it is more difficult. Radar is the easier way to go, and it utilizes image processing. So these are the phases of speed detection using image processing. The first phase is object detection, which is done through image thresholding. That will determine if an object is actually in your range of motion. It will separate the object from its background and will make the object very distinct, so you can tell that there is something there. And object tracking is determining whether or not an object is moving, and you will know that an object is in motion if, when you use the method of background subtraction, there will be a hole in the image, because there was an object in one spot in the first image and it's not in the same spot in the second, so there will be a hole there when you use background subtraction. So then you capture the image using the camera that you have available. I used the same exact camera that Carl and Josh and Kyle used, actually. And then the image gets sent to the Raspberry Pi, which processes it using the Python programming, and it will calculate the speed based on the position of the object and the timestamp of which the picture was taken. And then data storage, which is my extra step in this project, is I want to create a daily log of time and speeds of vehicles that are speeding to give kind of a deliverable that you can present to the authorities. Since you can't really do much about speeders yourself, you can say, hey, this is what I captured in my neighborhood, this is the time and speeds of the cars, this is a problem in my neighborhood, so that they can actually send someone out to do the patrolling for you when you have that data. And then I'd also like to store the images that the camera takes of the car, so that maybe you could get kind of like a red light camera situation where you could actually have a license plate and a car model. You can see better who it actually is. So this is an example of an image thresholding output. Conveniently, it is a car. The first image obviously is just your regular run-of-the-mill image from the camera of a car. The second image is with the image threshold applied. You can tell that the object is white and its background is black, so you can easily tell where the car is. And the third image is with shadow removal. So you can see down here that the object casts a shadow, which isn't that important because it is still kind of part of the object, but it is not of interest. So there is a shadow removal technique which the shadow can be taken out, which you can see in that one. So you have everything else removed in this one except your target object, which is your car that is moving. So these are my materials, my main materials. There are lots of subcategories with these. But the image you see on the left is the Raspberry Pi, and that's the Raspberry Pi logo on the top. It was developed very recently in the UK. And I chose the Raspberry Pi based on its hardware capabilities. It has an Ethernet connection, 2 USBs, and HDMI, so you can connect it to a TV or a monitor to use as your display. And it has audio, video. And how it works is you download the operating system to an SD card and just slip that into the Raspberry Pi, and it operates on a Linux operating system. And that's a picture of the camera that I'm using. I chose it because it is waterproof, which eliminates the need for a waterproofing apparatus on my part. As far as the camera goes, the Pi, as you can see, is very exposed, even with the clear case on it. So the camera is also, it has remote internet viewing, and it's also smartphone capable, so you can look at it on your phone if you choose to set it up that way, which is very convenient. And it also has night vision capabilities, which I'm pretty sure is where the infrared comes in with this camera, if I'm not mistaken. And so the camera seemed to be ideal for an outdoor setup since it was already waterproof. And I also had to obtain a wireless router from the robotics lab. I have been having major firewall issues as well with Mercer's internet, and the Mercer lofts also do not have Ethernet ports, fun fact. So I'm having to bum some Ethernet off other people on campus housing. So the wireless router allows the Pi and the camera to be connected to the same network so they can communicate with each other, and so that I don't have the firewall issues with Mercer's network. So my deliverables for this project will be the interacting camera and Raspberry Pi, which is the processor. The camera can take many frames in a second or a minute, and those snapshots can be sent to the Pi, which will then do the image processing with the Python language, which I have never programmed in Python before, but it's pretty user-friendly. And hopefully the images of the speeding cars I can store on the SD card, or it's also flash drive compatible with the USB port, and also my log of times and speed of cars on a daily basis. So do you guys have any questions? Okay.
Would you show me your, there's going to be a question, Emily. Would you go to your thresholded picture?
Yes.
So, A, is that black and white or color?
It's color, but you
color.
Can't really tell.
Okay.
It's color. The
and
car
then
is just gray.
The next one's black and white. That's all it is.
Yes,
zeros and ones.
that is with the threshold applied. You can make it other colors, but black and white is just the easiest to work with because it's very easy to see where the object is based on the black and white.
So to get from B to C, how do you figure out what the shadow is?
Well, there's a tool that will do shadow removal, and it can detect kind of the pixel concentration, like of the shadow versus the
Does it go back to figure A?
Yeah.
To do that? Okay.
Yeah. See, if you can't really tell on the screen. You can tell on the computer, but the shadow is just barely
I can see
under
the
car.
shadow there.
Okay. I didn't know if you could tell where the shadow was, but
so you go ahead.
Yeah, it takes the image, but the shadow is included, which isn't a huge issue, but it's also not part of the car, and it moves in a different way than the object does, so it's better to just remove it and take that out of the picture.
So figure A is used for the shadow removal algorithm. Probably
Picture B.
Picture B is?
Yeah, because it has that extra, that blob down there that's not part of the car. It's used there.
Huh. I guess I can see how it would do it in A, because it's got more information, but to me, once you get to B, it's just zeros and
I
ones.
think you could, well, because see, this image is a derivative of this one.
Right.
So it's kind of like a combination of another thing which is called matrix, adjacent matrix subtraction, which I did not go over. But since C is a derivative of B, it just kind of has to go around the circle first.
Okay.
And I probably won't utilize much of the shadow removal because it is very advanced with an image processing software. So, and I have the Pi to work with, so.
So then when you do your speed, you'd be working with image C.
Yes.
And in theory, you'd see, image C would be you'd see the blob moving through.
Yeah, you'd have the blob in one spot in one image and the blob a little bit further in another image so that you could tell where the distance that it moved with versus the timestamp of the picture that was taken.
To do the speed, are you going to use like a leading edge, or are you going to use a center of mass?
Probably leading edge, but I'm not quite sure yet. I'm still very early in this project because I have had so many network problems. It's just been crazy how many network problems I've been having. So it's severely hindered my project so far. But I was planning on using a leading or a trailing edge.
And then, because in this particular image, you'd be able to do the capture of like the driver and, well, not a license plate, because in Georgia they're always on the back.
Yeah.
But
this is obviously represents more of a red light camera type thing because it's very up in the air and it's kind of has a front angle. I was planning to do a side angle so I could get the whole car, the side of the car in the picture, so then I could easily see where the leading and the trailing edges are.
Great idea.
So, yeah.
And then the math will be nice on a curved road like mine, because you'll have to take into account
the angle.
curvature of the path, of the speed.
Yeah.
And generally when people are speeding, they're on the wrong one side. They're either off the road running over mailboxes, or they're in the yard on the other side of the road. So.
Yeah. And I was originally planning on installing this apparatus in a mailbox, but I actually discovered that it is illegal to put things in your mailbox that are not government issued mail. So that's where the waterproofing apparatus came in. So that's why it's very convenient that I have a waterproof camera. So.
Then Python is used in movies, is that correct? Is that right, that Python is used?
You know, Dr. Dye?
Is that done with movie images? I thought in the book by Randy Couch, I thought he talked about Python and the use of it in the new Star Wars movies.
Wow.
I thought that was what the programming language they use for a lot of the graphics and things.
It might be, because Python is pretty user friendly and basic. I sat in on a Python class when I was applying to undergrad at Georgia Tech, and it was the class that all the sorority girls were in because they were required to take programming. So I figured it was at least a little bit easy to understand. I can say that because I am one myself. So for people who aren't going for computer stuff, programming is just like, so, yeah.
I was just wondering, is this set up to be like stationary, or could it be mobile, kind of like a radar gun? Like, does it have to be calibrated to an area?
I was planning on having it be stationary just for the ease of use, that you could just set it and leave it. And really the radar is easier to use if both source and observer are moving, because radar, the Doppler effect, measures the relative motion between the two of them. So that is how the speed is calculated for if you were moving and a car beside you was moving or in front of you, you could calculate the speed based on the relative motion between you and the car that you're measuring. So radar would be more effective in that aspect. So I was going to have it be stationary so that it could take easy pictures and you could just set it and leave it. And it would be okay. Does that answer your question? Yeah, Dr. Icon.
Do you envisage any future legal issues, especially related to privacy?
I did think about that, yes, and that's the reason that I chose just to have a daily log for use of the resident and nothing else, so that they could really see maybe if they're overreacting about the speed problem. If there's only 2 or 3 speeders per day, maybe that's not as big of a problem as they think, but if it's every hour you have 5 people speeding through there at 55, if the speed limit is 35, they could discuss it with the authorities and say, this is what's happening in my neighborhood. It's really disturbing my daily life. Is there anything I can do about this? Because issues like that were brought up when I first selected the project, and I definitely did not want to meddle in anything the authorities were doing. So that's why I kind of kept it on an individual level, so that the user can decide what they want to do with the log. So.
I actually had a long conversation with a technology and society person about that. If you put one of these up and it loaded speeders in my neighborhood and just put the picture of them up to the web, technically they're driving on a public highway. You are allowed to take photo of them. You know, so I mean, it's not, you know, like you're trying to zoom a camera into their house and see what they're doing when they're on, you know, public property at that point. So he said, but he was interested in using it in a discussion in his class about privacy issues and computers and things like that. So,
Yeah,
particularly in
Dr.
the age of when
McCrainer
everybody's-
did discuss with me maybe directly uploading their pictures onto a webpage
Yeah.
and saying, this is what these people are doing.
Yeah.
So.
Is this you? I'm looking for
Yeah.
you. Thank you very much.
Thank you.